All right, welcome back, physics nerds. Mr. Thompson here again. Page 81 of the workbook. We're looking at Snell's law and critical angle. So we'll do a few practice questions together. So A, part A, number one. Light travels into a medium X with an angle of 25 degrees with respect to the surface. If the angle of refraction is 17 degrees, then find the index of refraction for the medium. Okay, so what I'll do is make a quick sketch of what this looks like. Try and estimate my 25-degree angle. It's not a big deal. Okay. Draw in my normal line. And draw my refracted angle. Okay, so the ray is going in this way and down into this medium X. This is 17 degrees, and this here is 25 degrees, meaning that this incident angle here is 65 degrees. Okay? Now it's going from air, I presume, into medium X. And so the way I like to set this up is I like 1s and 2s are just fine. Okay? So if I call this medium 1 and this medium 2, then I can set up the equation as follows. Now I want to know the index of refraction for medium 2, and so I'm looking for the variable n2. Okay? That's what I need. So let's set this up. I have sine theta 1, okay, over sine theta 2 is equal to n2 over n1. Okay, now what I'll do is just put in my numbers here. I have sine 65 degrees over sine 17 degrees is equal to n2 over 1.00. N2 I'll get as pardon me, let's put a little bracket in there, 3.1. Question number 2. Light travels from water, n equals 1.34, into air, and the angle of refraction is 72 degrees. If the wavelength of light in water is 510 nanometers, then find the angle of incidence. Okay, so we're looking for the angle of incidence. Now it's going from water to air. So all of my 1s, okay, are going to be like the incident. So, okay, and all of my 2s will be out into air. Now I want to know the angle of incidence, and so what I'm really looking for is theta 1. Now when I look at the information I have an index of refraction that's given right here, 1.34. I know errors, so I know the n values, and I know one of the angles, so I can figure out the other angle. Let's set up the equation. So similar to the previous one, sine theta 1 over sine theta 2. Let's get this up a little higher for you. Is equal to n2 over n1. Now I want to find this for a value, so I'm just going to put in what I have. This is sine 72 degrees, and n2 is into air, right? So 1.00 over 1.34. Now I'm going to figure out what sine theta 1 is, and then what I'll do is I'll do the arc sine to figure out the angle. Okay? So I'm going to take 1 divided by 1.34, and then I'll multiply by sine 72. I get this number, 0.70974. So theta 1 is inverse sine of that value, and I get 45.2 degrees. So for part A, that's what we've got. Let's take a look at part B, the wavelength of light in air. I'll just get a little more room here. Now you might want to hold that sheet near you so that you can, if you did what I did, and then you can always use it to reference some of the information, okay? Because that, of course, angle can be used in subsequent calculations if you wish, okay? All right, so 2b. So what I'm looking at is the wavelength of light in air. I have the wavelength in water. I have the indices of refraction, and so it works like this. Okay? We have the wavelength in air over the wavelength in water is n water over n air. Now that's a nice way to set up the problem where you're using A and W. Now if you didn't like that, then you can go back to what we did before, which is just fine. You have water is 1 and air is 2. And so the wavelength in air would be lambda 2. Okay? Over the lambda 1 equals n1 over n2. It's up to you to decide what do you think is most comfortable for you. Okay? I kind of like using these subscripts, so keep that in mind that I like to really kind of rely on that because I don't need to think too hard. I know what I'm looking for. The wavelength of light in air, I know I'm looking for this variable right away. Okay? Here I'm kind of like 1 and 2, which was which? All right, I'm just going to go ahead and start from the substitution with this step right here. Wavelength in air, wavelength in water, which is 510 nanometers. I won't convert that, I'll just leave it the way it is. And water was 1.34 and 1.00. That gives me wavelength in air of, well, 1.34 times 510, 683. Now the units will still be nanometers. All right, let's take a look at 2C. The frequency of light in water. Well, the frequency of light in water is equal to the frequency in air. So I can use either the water data or the air data to figure out the frequency. What we'll do is we'll use the universal wave equation because the frequency is the speed, okay, which we can only just use as v now because we can't use c interchangeably there since it doesn't travel at the speed of light in the material or in the medium, in water, and that would be over the wavelength. So we're using the universal wave equation. All right, so I'm going to go ahead and choose the data that I want to use here. Now I know I have the 72 degrees for air. I have, right, the speed in air, and so the frequency is just going to be 3e8 divided by the wavelength, which was I got as 683.4. Now this is going to be nanometers though, so you need e negative 9 there. Okay. Pardon me, 3e8 divided by 683.4 e negative 9. Why didn't I put that on there? All right. I got 4.39 times 10 to the 14th. And the units should be hertz. Okay, that gives you a couple of examples to go on. I'll come back in a moment and do another one.